Your homework for tonight is to finish the two problems up above to add together the area for this graph for 4 rectangles, 4 right-end rectangles, as well as for 8 right-end rectangles. And when you're done with that, I want you guys to do these problems down here at the bottom. So I'm going to walk you guys through this first one, and then I'm going to let you guys do the last two on your own. So I will show you how to find the area under the function 3x plus 1 on the interval from 1 to 5 with 4 rectangles, and then again with 8 rectangles. And so the first thing I want to look at is I want to look at a rough sketch of the actual graph of 3x plus 1. So if we graph it, very, very rough sketch. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So 3x plus 1 has a y-intercept of 1 and a slope of 3. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Obviously, this is going to go off my paper. Did not plan for that. 1, 2, 3, 1, 2, 3, 1, 2, 3 over 1. All right, so it's going to go off my paper, but you get the point that this line continues up like that. Now, as far as the intervals are concerned, I only care about x equals 1 to 5. So I'm only looking at this interval right here in the middle. And part A said to divide this interval into 4 rectangles. So as you can see, it's pretty evenly split, that we have 4 intervals. There's 1 interval, 2 intervals, 3 intervals, 4 intervals. So to make them all the same length is not going to be very hard. And in this case, actually, it's quite easy because they're all of length 1. So 1, 2, 3, 4. And each rectangle is going to have a base of 1. So far, we've only talked about right-end rectangles, so we are going to continue to talk about right-end rectangles. So if this is the base of my first rectangle, then from the right-hand side of my rectangle, I'm going to shoot straight up from 2. So straight up from 2 is right there. And then I can also draw the other side of my rectangle, and I just have to close off that rectangle at the top. So this rectangle has a base of 1 because the length of the base is 1, and the height at this point was, if I plug 2 into the function 3x plus 1, so I guess I can create a little t-chart right here. If I plug 2 into the function, I get 2 times 3, that's 6, plus 1 is 7. So the height of this rectangle is 7. And I need 4 of these rectangles, so I'll do my next one. I'll do 3, shoot straight up to the right, comes across, and then down. Again, the base is 1. The height, if I plug in 3 to this equation, I get 3 times 3 is 9 plus 1 is 10. So the height of this rectangle is 10. And then from there, it's going off the top of my graph. So I won't actually draw the other rectangles, but you can see that they would be, sorry, that rectangle wasn't very good, but they would be in these places here. So there'd be 1, 2, 3, 4 rectangles, just like it asked me to. So if I plug in 4 as the right rectangle for, this is A1, A2, A3, and A4 will be down here. So if I plug in 4 to this, I get 4 times 3 is 12, plus 1 is 13. And if I plug in 5, which is my last endpoint from the right, I get 5 times 3 is 15, plus 1 is 16. So these are the heights of my rectangles, and I know that the base of the rectangles is each 1. And so if I want to find the area, the estimation of area, it would be base times height. That's A1 plus base times height. That's A2 plus base times height. That's A3 plus base times height. That's the last rectangle, A4. Notice, by the way, that because we're forcing the bases to be the same, I could have just multiplied by 1 at the end and just added the heights together. So you can do that with all of them as well. So as long as the bases are all the same length, you can add all the heights together and then just multiply by whatever the length of the base is at the end. So if I do 7 plus 10 plus 13 plus 16, I get 17 plus 29, which is equal to 46 units squared. So the estimation of the area under this curve from the right with 4 rectangles is 46 square units. Now I want to show you guys briefly a Desmos of this. So here I have the function. Here, I'll point to it on your screen so you guys can see it as well. Here I have the function 3x plus 1. And then down here, let me open this Desmos application up. You'll notice that I have my left endpoint set at 1, my right endpoint set at 4, the number of intervals or the number of rectangles set to 4. Down here it tells me to choose if I want left-hand sum, right-hand sum, or the midpoint sum. So I entered in 1 because I want the right-hand rectangles. And then if I close that, you'll notice down here this is a crazy formula that we'll talk about in probably the next couple days. But this is essentially the estimation of what the area of these rectangles are. So notice that it says I equals 46, which is what we just got when we added up the area of these rectangles. So let's change a few things so that we can actually get the answer first for part B of this problem, and then we'll go back and actually do the math for this problem. So part B says to do the exact same thing, but this time we're going to change it to 8 rectangles instead of 4. So notice over here I have 4 rectangles. You can't really differentiate them since they're all the same color, but they're all these vertical ones. So let's change the number of intervals from 4 to 8. And notice that now I have 8 rectangles and the area is going to be a much closer approximation. So if I come down here again, it tells me that the estimation is 43 units when I have 8 rectangles. So let's go through and look at the steps for how that happens. Now, before we get into this next part, part B, let me just make one more quick mention about the spacing for how far your intervals should be apart for these rectangles. For this one, it was fairly easy to see that with 4 rectangles, they were each going to get 1 unit of length, and so it was easy to space them out. It might not always be that easy, and it might be kind of a weird number that the rectangle's length of the base needs to be. And so there's a little formula you can remember. So the number of rectangles, so we'll use n to be the number of rectangles. N equals the number of rectangles is corresponding to this formula. So b minus a divided by, I'm sorry, n is not the number of rectangles. It is, it's just not here. This is the spacing, or the base. So to figure out how far apart the rectangles are, or to figure out how wide the base of the rectangles is going to be, you can use this formula, where b is the left endpoint, so 5 in this case is b. B is the right endpoint, a is the left endpoint, and then n is the number of rectangles you're looking for. So to figure out that each of these rectangles for the first one was going to be of length 1, I could do 5 minus 1 divided by the number of rectangles that I wanted, which was 4. So that's 4 divided by 4, which is 1. And that tells me that the base of every rectangle should be of length 1. So doing the same thing for part B, to figure out the length of the bases, I should do b minus a divided by n. So in this case it's 5 minus 1, because I'm keeping the same endpoints, divided by the number of rectangles that I want, which is 8. So this is 4 divided by 8, which is 1/2. So the base of each of these rectangles is going to be 1/2. Now again, we're going from 1 to 5 in half increments. So that's 1, then we have 3 halves, then 2, 5 halves, 3, 7 halves, 4, 9 halves, and 5. And because we're doing a right end rectangle, we're always coming up from this side and making our rectangles go like this. So we're always coming up from the right hand side. So I've created a little chart. So the first number I'm going to plug in is 3 halves, then 2, then 5 halves, then 3, so on and so forth. So let me just write these down. 3 halves, then 2, 5 halves, then 3, 7 halves, then 4, 9 halves, then 5. So these are the x values of the right endpoints, which I will then use to find the height of every rectangle from the right. So when I plug in 3 halves into this, I get 9 halves plus 1. That's 11 halves. By the way, you can use a calculator for this. I don't necessarily need you to add these all up by hand. 2 times 3 is 6 plus 1 is 7. I'll put this on pause and do the rest of these, and you should do them as well, and then check your work. So pause the video now. Alright, so the heights of each of these rectangles from the right end points, and again notice that there's 8 of them, are 11 halves, 7, so on and so forth. And remember that I told you up above that I don't necessarily need to multiply base times height for every single one, because all of the bases are all the same length. They're all a length of 1/2. I'm going to multiply 1/2 at the very end. So I have area equals 1/2, which is the base for every rectangle. And then I'm just going to add together these different heights. So 11 halves plus 7 plus 17 halves plus 10 plus 23 halves plus 13 plus 29 halves plus 16. So again, pause the video and add those together, see what you get, and then let's check. We should have gotten that same answer that we got before when we looked at Desmos. Alright, so when I added all these together, and I got 86, and then I divided by 2, and I got that it was 43 units squared, which was the estimation for the area from the right when we used 8 rectangles. And again, I believe that's what we got when we were over here looking at Desmos. Yes, 43. So that's how you do these by hand, and we're going to practice doing them by hand for just a little bit until we can get back into the calculus of it and looking at the math behind it. So I want you guys to, again, I want you to finish the following. I want you to finish these two, all right? And then I want you to do number 2 down here at the bottom as well as number 3 right here, and then turn that in tomorrow.